Hi everyone, and today we will talk about product security, and we'll have a look at how product security can be viewed under a new angle. We will define what is product security, understand why it is important and how important it is, how we build the process for product security, and understand which roles are exist in this process, who plays what, and in the end, I will be talking about the results we received in our company Reich while building the product security, and draw some conclusions. Let's go. My name is Dmitry Desyatkov. I've started my career in IT as a developer and Java developer. In 2009, I joined application security industry, where I started to analyze source code, work with developers, and do trainings. In 2014, I joined Reich, and I joined in exactly the moment when there was no special person for information security. And I'm the person who was building different types of security in Reich. The whole security issue for us is information security. And now I'm an information security director for Reich. It has quite a lot of organizations. We have our product, we sell it. We have different offices in different countries, Europe, Japan, Australia. We are opening an office in Czech Republic, and that's not a coincidence. Information security has played a huge role here. We are currently ISO certified. We are re-examined for compliance with SOC 2 Type 2 requirements, yearly GDPR audits, if you can call it an audit, of course. We check how the functionality is realized both in the organization and in our product, and a lot of other questionnaires that everyone can feel like CSA, Cloud Security Analysis. Let's start with what product security is. Let's see what types of security exist on the market. We know that system security, network security, infrastructure security, DevSecOps, very much loved by everyone and hugely talked about, and risks and incident management and application security. And the question is, do we need anything else? Do we need some specific product security area? In all the segments of the internet, product security is equaled to application security, but it's not correct. At least it's different words, and application and product are different things. Let's define or look at the definitions that are given by different companies or regulators. For example, in one big company, application security was defined as an IT discipline that has to do with security or regulatory compliance as part of specific application projects. ISO defines it as a process, and pretty much everyone knows how to build it. In most conferences on IT security, the process is shown as SDLC, secure SDLC. You need to do this, then you need to do that, and you will have your app security at the highest level. And it's true, it works. If you run application security in a certain way, your application will be quite secure. At least you will have good practices in your product life cycle. You will have good practices in development. Your developers will analyze the source code. You will have quite serious process on deployment and support of your application. And so this is about an application and everything that is connected with it. Threat modeling, vulnerabilities, exploits, all the measures you can take on the application level to reduce the risk of this or that vulnerability type. So the main goal of application security is establishing the process. Whoever says differently is not right. Pen testing, that's not it. It's a process that has its roles, and the security plays a significant role here. From the application point of view, the application security process goal is to make all the applications secure, which means that they don't have known vulnerabilities, like WASP Top 10 or some others. At least they don't have any vocal and vivid issues with the security. As a result, there's some application security requirements that the application needs to comply to. This is risk management, risk estimation. It's good when you attach different security feature development here. Why I say it's good? Because it's not always the case when the application security team can dictate some specific requirements to the business. They often cannot say, let's not do this, let's do multi-factor authentication or encryption. And this is wrong. This is not good. Unfortunately, application security doesn't often have this luxury. Let's see who delivers application security. Which players are there on the market? We know it's outsourcing companies, these are service providers and product teams. You will definitely say that there are companies here present that develop software for security software companies. Yes, I agree, but I would suggest we consider them not as in this scope, but separately, as their first goal is to monetize security. Product security has a lot to do with this because they have a product, security product, and it's well connected. And I will show you how being an ordinary product company, like I work for, to come to security in terms of monetization, how you can build the business based on the security as part of your business model. Okay, let's come back to the companies. What good or bad arises for the service providers? They have a lot of projects, different applications. They need to cover specific application security requirements. They don't have enough resources, and they look like a board. In one board, they have a security team, and in the other board, they have engineering and business. And both teams of both boards have a ball that travels between one board and another and represents different vulnerabilities, issues connected with application security, or risks, formal and non-formal risks. Security team sets it to the business, then the business accepts them or not, and so they play some kind of ping pong with it. In a product company, they have one board, and the whole team sits in that board and rows. And all they have is with them. It's inside the board. You cannot drop it or pass it to somewhere, and in fact, it's kind of a ballast. But also, it is a measure allowing them to deliver the quality to the users, and it affects the competitiveness of your product. And it's great because you are not alone here. If you are not rowing, then someone else is rowing instead of you. And good organization of this whole boat allows also for the security, but in general, to develop the product well. And so we come to this picture where the product security is some extra layer above application security that includes not only the processes we've been talking about, but also business logic. out of the companies selling application security, who is understanding the business logic of the application they analyze? It's not often, but it happens sometimes. I know examples, but it's a rare occasion. Even based on the service we are purchasing yearly with pen testing, it's pretty much never they find the vulnerabilities and issues we know about. Well, we know our product, our business logic, and its SLAs, because we work on it every day. And of course, the communications are also included here. The way one system calls another application. We also have mail processing, and this all is tertiary priority. And as this diagram grows when we look at the application from different angles. As Mark was mentioning today, there was an interesting thought that I would like to repeat, and it has to do with the customers are really worried about security. If I buy the product, I want to know what happens within it. I need to know what data it has and how it's managed and what happens. Usually when you buy a product, it's like a person from marketing says, I want to buy this software. The security team says, okay, here's the questionnaire, let them fill it in and send it to us. Or send us some security artifacts, penetration testing results, SOC 2, ISO certificates, etc. And then the security forgets about the product, and that's bad. The current threat is to monitor your vendor in some way or another, but not to assess the vendor once, but constantly keep receiving the alerts and keep monitoring the vendor. And the task for the product is to be ready to the enterprise ERP system, and it's a very serious task. Application security cannot solve it. And of course, user behavior plays a significant role. Application security situation with two-factor authentication, you check that everything is fine, there's no bypass options, but no one uses it. And did you make it well? No one knows. The product security would also address this issue, like how does the security functionality you've implemented is used. So here we get a goal for the product security team, and that's organization of the team organization, meaning everyone in your team, information security, engineers, developers, testers, they need to be on one page to understand their product. They need to have the same onboarding trainings to understand which components are there. They need to be together. Of course, product security that includes application security would inherit all the goals of application security, but with a limitation, in the sense that it not only builds the processes, but also defines the correct communication between the security and engineering, right communication inside the information security team. It is hard to ensure information security when the infrastructure security guys are not talking to them, when they just look at the SOC and see some problems connected with access, and then don't report it. And if they reported it, the product security team would fix it. The metrics play an important role. What are the metrics for application security? The amount of bugs, risks, cases passed, and it's a good case. But no one is looking at the way the product works, the health of the product, and it's important to monitor the product health and understand how tightly the engineering and security are integrated. The amount of open and closed defects and bugs is a good metric. Okay, so if the amount of open bugs decreases, then the product is getting healthier. The need to avoid issues leads to interesting stories, like the guys having a requirement to make a release without high plus defects. So what the developers were doing, they were entering Jira, removing the high plus defects from there, then making the release, and then the developers would say, "Hey, we need to suppress those bugs," and the shadow development would continue. It's not good, of course. And of course, we also mean and include security features. And all the features need to be secure. All the functionality should avoid WS top 10. And the information security function here is to say, hey, the astrologers have announced the year of two-factor authentication or CM integration in this year. It needs to be done. It monitors the market. And there are a lot of interesting moments here. As itself, but it's a bigger thing. It's another layer on top of the security features. It's the specific features that the customer, the user, can run to understand what's happening with the security of the product. So if we buy some product and want to work with it, I, as an owner of this product, want to understand what is the data, what is the levels of access to this product. And to ensure this, I not only need the convenient access control, but I need to provide the user with the capability to monitor this access and to trigger some behavior when someone, for example, has received access to it. Good idea might be to enable logging to know all the events. But the customers would not know it. So they would want to integrate with their own CM. So the product needs to be integrated with the enterprise ecosystem. And this is one of the important points of my presentation. Encryption. Everyone says we have everything encrypted, no one has access to it, we store them securely. We say we have encryption at rest. And if you ask what it means, they say, yeah, the file system is encrypted. Okay, so once you mount the disk, it's encrypted, then you just wait till it's till the other launch. So all the enterprises would want to purchase some on-prem solution instead of working with SaaS, because they understand what happens on their own infrastructure. And this is an important factor too. So I highlight this moment of features for security as an important layer. It's not just features that are dictated by the market or the trend. Epifx was hacked, everyone, all the data was lost, everything is hackable, you need to install some software to avoid this hacking. So this is a trend that is dictated by, that dictates by which baselines you need to have in your product. And those baselines are followed by your customer, your user. You will not enter the market without some specific security functionality implemented. On the enterprise level, you will not be able to play without main security features like audit or encryption, two-factor authentication, logging, etc., etc. At the same time, the two-factor authentication is not needed by the enterprise. 2FA is used by 1% of the enterprise according to our analytics. They require it, but they don't need it, they don't use it. So now, the accent is focuses on adding this functionality. Not only enterprise, but also small and medium businesses looking for this functionality. So we talked a lot about application and product security. We have other layers of security though. SOCs are being built, other stuff is going on. So here is a set of the main trends in both business and security that product security has to address. And first of all, it is business strategy. You cannot create product security if you don't know where the product is moving. You cannot say this needs to be done. It is just a waste of time and resources to implement such functionality. And of course, the security culture is here. And how well you work with other departments, conducting trainings, beautiful and nice phishing attacks, so the users as your own users would betray you. Both network and application security is here. Everything that has to do with internal corporate network, because your product can be hacked through your admins, through your accountants. It's also here. Product security looks attentively at this and understands whether it needs to be developed or not. The risks that are not only connected with the product itself are here also. Additional moments with product deployment, DevSecOps. Is it part of application security or not? Probably not, from my point of view, or from my point of view of my religion. It's something extra. Compliance. None of the enterprise customers would purchase a product without certifications. Americans say we need SOC 2, Europeans say ISO 27001, and still they send their surveys. And the most important here is that the level of the product security grows when the sales team starts to talk correctly with the enterprise. They say we have that functionality, it needs to be implemented in this way, and they sign the deals because of the security as an important factor of an overall sales cycle. And the marketing can sell it, can advertise it, use it as a value. So product companies are well known on the market. They are integrated with other security products. Even Bug Bounty SaaS shows to the market that the company is investing into security. Whoever finds a bug, we're gonna pay it. So there's a pyramid here, and as a base for the whole product security, there is usual security baseline. Just fix this, try not to put admin password, then infrastructure security, vulnerability management, structural level, application security processes, communications between engineering, product security. You add things connected with logic and how the product develops and the market develops, forecasting and strategy discussions with the business and relationships with the salespeople and marketing people are added here. So we can define product security as a combination of different security domains or areas in the security field that includes application security, system security, network security, incident and risk management, and compliance. But an important part here is played by the product. Product managers who help to build or develop or improve the security functionality or security for functionality. It's a mixed definition, but I hope it's very useful, so I understand you now feel better about what product security is. So when anyone tells you that product security is just building a process, tell them, no, you've listened to Dima and he said otherwise. Let's look at which roles we have here, who is responsible for what, who impacts what. So we have some lines of business, external people, internal stakeholders, internal security specialists, operations, and external departments. So who are the stakeholders, the external stakeholders? Your customers, our customers. The market. The market dictates specific requirements or conditions. If the market says this company was hacked because it didn't have five-factor authentication, then everyone will go and have it. So those stakeholders, external stakeholders, are pushing the requirements to the internal stakeholders, business owners responsible for the product development. That some department will analyze and define whether they need to go into production. Then the internal stakeholders, based on their understanding of the product, create the tasks or stories, whatever process you follow, the implementation for engineering teams. How is this security related to the external stakeholders? So they fill the questionnaires and understand which big achievements were happened. It has a backlog of the requests, so if there is a requirement for some specific functionality, the critical mass is filled, and the security team orders the developers to, for example, implement five-factor authentication. Then the internal stakeholders would say, yeah, okay, let's see how we can make it happen, and if the users really demand it. So, and the last arrow here is application, infrastructure, system, and incident analysis, so communications between security and engineering. Here are the roles that exist as part of the product security. And here's how they affect the business. So let's see how it all worked out in our company. Till 2015, there was a lot of security, as I said. For some years, we were just fixing vulnerabilities, creating or implementing the design and refactoring, doing serious authentication changes, improving the data protection and storage. Here's what our first step consisted of. Bug fixing, security requirements, authentication. We implemented SSO, ensured file encryption, because the customers were worried about the file security, so we decided to encrypt them to lower the temperature. Then the next step is the building of the information security team, communication inside the department to the external departments, security feature creation, functionality creation. Then we had SAML here. We started to address mid-market, and the customer said, yeah, we want SAML. As part of it, we also realized two-factor 2FA, and we understood it's not needed, because when you have SAML, you don't need 2FA, because the whole authentication is on the customer side. Well, we were mistaken, thinking it's useless. It appeared to be useful later. The second part of two-factor authentication played when the enterprises started to hire external vendors to their workspace. They are not in corporate Active Directory, they cannot use Okta or OneLogin, so they needed to have login and password with two-factor authentication requirement. So first, it helped us win deals in mid-market, and smaller enterprise. SAML helped us to address enterprise level, and 2FA has just appeared as a requirement in 2018, voiced by big enterprises, understanding that as part of their internal identity management systems, they cannot solve the issue of external vendors. And then the policies, the password policies and network policies were created. A lot of work was done to protect the data. We went out away from the PCI certification, understood we would like to rather work with a payment gateway rather than create something new by ourselves. And then we were certified on data protection. Then we started to certify our product security team. This team had more to do with PM organization rather than product security, but this team had a lot of knowledge about the product and application security. They worked closely with information security to create the functionality that the customers needed. And things like how do we make it right, how to make it logging right, what does the customer needs. So the monetization line of business was created to monetize the product security. And we had a significant advantage in the fact that all our processes, information security processes, were based on our application. Vulnerability management, application security, inventory. So we had, and compliance also, we had everything in our tool. I will show you later. During that period, we've done a lot to be ready and to dive into the enterprise security ecosystem with encryption, with security settings. At least it was not implemented fully, but at least it was part of the development process. We had CM system integration for customer, and the last step that where we are now is we are trying to go deeper into considering security as part of our business model to ensure that we use security as in the business to ensure that security moves from a cost center to a profit center. So you remember probably a lot of people talking about how do we discuss we need security, but here's the answer. You need to make your security drive revenue. Your deals will close only when you have good security. And we have a line of business to develop applications for security. So we used to be a project management system, but now we have a security application. During this period, we have added CIM functionality, user provision, granular permissions. Last year, it was #1 in popularity. So granular permissions have grown. Monitoring and alerting, but not just monitoring, but with good reporting and behavioral analysis and data protection. So as a result, we have launched encryption at rest to encrypt what we have in databases and manage the use the customer encryption key. So he has its own the right to remove its key. So now we have like as a collaboration system.
That is, all the parts are here, and they're locked, they're safe, and this would be, that is, we are guaranteeing the trusted coworkers where ensuring very safe communications, and we also guarantee a safe data storage. And to this end, we have a certain functionality which helps us to solve the three issues: prevention, detection, and respond. We have the many functionalities I've already mentioned about the data protection, about the authentication, authorization, access control, and our users can see at the result of what's going on, and also to issue monitoring reports, activity reports, internal monitoring, and the access control report. Well, and by doing this, we turn RIKE into such a machine, which enables you to do everything basically throughout the whole process of an enterprise. We can also consider it as an enterprise, and we also want to build GRC related different mechanism. We have the RIKE, which enables us to manage risks, to manage incidents, to do vulnerability management, and it looks pretty good. And it looks something like that. We have the functionality which can create different statuses of a particular task or assignment. And here we have an opportunity. For example, risk management. As soon as you generate a risk, it has a status, and the security team analyzes, evaluates it, and transmits it in a certain status. The subtasks enables us to build the mitigation plans. If all the tasks have been closed, or the risk is either eliminated or mitigated in a big way. Next would be the forms. As an interface for any communications, we even have an external form on our website. You can look at any vulnerability if found, and we consider it if it's not a duplicate with somebody else, or if we're speaking about the internal vulnerability, we do this kind of internal bug bounty, which we pay out. We can also map different requirements, different compliance for internal entities, internal framework, and the security control, which is doing cross-mapping between different certifications, ISO, XOC, PCI, and different ones, different frameworks. This is what GDPR compliance looks like. Going through compliance, it's a check. Everything is cool. We have all the functionality. If something turns out to be not cool, we build certain tasks which have to be done to cover this security issue. This is what going through audit looks like. You can see requirements within certification. ISO 27001, and there is a certain security controls which have to be performed in order to change status, like automatically or semi-automatically, either pass or fail. On this basis, we build reports, what risks are available, what the status of these risks, and then we do the report send it to the management. Also, all internal inventory is here. We can see what kinds, of vendors we have. Who of them is working with what department? Either state is either critical or non-critical, and in this way now we can using this security track, which covers the following list of processes, such as working with vulnerability incidents and risk management, all the developments, software development activities and processes, integration with JIT and other systems, issuing access control. All of this is done via a form automatically. Line management, who is doing the approval, etc., and inventory, including compliance, audit, and business continuity. It's all in here. As am I finishing up, I would like to say that this product security is very important if you want to go on building your product, if you know it very well. So calm down, study your product very well, and this application you're working with, and make the most of it than simply task management. Product security is the very tool which makes your product a quality one, which makes it competitive on the market. And this, in turn, enables you to move away from security as from a cost center to a profit center. Thank you.